We're back at the 2018 AGU 4 meeting. AGU TV kicks off right now. Hello and welcome to day 4 of AGU TV. I'm your host, Stephen Hall. What an exciting week we've had here at the AGU in Washington, DC. We've covered the main events, we've spoken to the biggest names, but we're not done yet. Today we're interviewing top newsmakers and we're touring universities and organizations doing exciting work in science. Well, we're absolutely delighted now to be joined by Andy Revkin. Andy, welcome.
Great to be here.
Thank you ever so much for taking the time to talk to us today.
It's my pleasure.
Tell us a little bit about your current role, what you're up to.
I started at National Geographic Society, which is the .org part of the National Geographic universe in March. So I'm a newbie, and I first thought about going there in 1980. When I was just starting to think about journalism, but it's taken me a long time and here I am. And I'm mostly, right now, not writing. I'm mostly there to facilitate, to sort of energize and support and actually fund breakthrough journalism, communication, and inquiry, and education, and technology innovations using data for sustainability.
So there are around 28,000 people who might be interested in one of those facets you just spoke to, either in securing grants or telling their own sort of science stories. So my question is really, how is it that we start to bring climate change and environmental stories, the stories of hope and action, into the fore in the media? I think we talk a lot about doom and gloom. Ice sheets melting rapidly.
Sure.
How do we tell the stories of action and hope? I get to experience those, but I don't see those.
It's I think, well, what I've learned since 1988 when I started writing about this, and this is pretty doom and gloomy, and the whole thing was about, oh, you must do this, it was everything we've seen ever since, sea level rise, etc. What I've learned in 30 years of inquiring on this is that the best thing to do is to split this in pieces. That global warming and climate change, first, they have so many different meanings culturally and scientifically, that if you're just saying global warming, there's a new study saying it's warmer, that doesn't really have any action points. But when you dig in on vulnerability, what makes us vulnerable to the things the climate system does, there's 1,000 stories there. And when you look at the energy side too, emissions reductions, new energy frontiers, there's tons of stories there. And as everyone has learned in the climate journey, there's no one answer anyway. This idea that we would have some treaty, a top-down approach to a treaty that would kind of have everyone doing the same thing and having some kind of shared system of punishment and reward is just not going to happen. What happened with Paris is that got translated now into a much more flexible approach, nationally determined things. And that makes it all the more important in different countries to be assessing, well, what is it in our landscape in India or Thailand or the United States that we can do actively to cut vulnerability, explore new energy frontiers. And then suddenly it's not that thing that everyone's fighting about.
So how do you, we just spoke about the international and national sort of scale of the issue. And what about thinking about media on a national scale, but then hyper-local? I see a really important role in my community for local journalists to be telling and making those connections for their communities, because often our readers don't necessarily only look to the large national outlets. So what is the role of starting to tell those place-based positive narratives in local news? Just any thoughts?
Well, it's a sweet spot for us right now. We're starting a partnership. I can't really say more right now. That's a collaborative reporting experiment in a watershed in the United States to get the media that are scattered around a watershed, most of which are struggling, small, and maybe some bigger entities, to have a co-reporting approach to living in a watershed. And that's kind of like a really cool prospect. If we can make it work, it's an experiment. So, and then in Ohio, there's a journalist I met at something called the Solutions Journalism Network, which says a lot about what's happening in journalism right now. What can we actually do that's useful? As opposed to just saying he said, she said, or whatever. And they are, he's pitched the idea of a national network, collaboration around exactly this point. And I think those are the exciting prospects. And there's one other element of that, which is for the community, to enable the community to tell its own story and do its own exploration. And there's a bunch of experiments like that underway. Thriving Earth Exchange is one, but there's others too.
It's a tough call, isn't it? Because you've said that it's not one big issue, it's lots of different issues. But if you look at journalism today, I mean, the ability to have that amount of expertise within newspapers that are closing down or shedding stuff, how does that even work?
No one knows the answer to that yet. We're doing, at National Geographic, we've created, and we're expanding this grant support mostly for independent journalists, the ones who may not be full-time in a newsroom anymore, to tell ambitious stories. These are grants that are for early career grants, which for anyone 18 and up. Right. So, journalism students, for example. And then there's bigger, up to like $40,000 grant for someone at a senior level to kind of dig deep on an issue. And with that kind of support, then you can sustain having this kind of reporting flow around. It's a different model than everything having to sell itself, and then a subscription model. Everything there is kind of open questions.
I do have one final question, which is sort of, in my career as a journalist, which also goes back a long time, I've always said to some extent the public gets the media it deserves. And is there a public appetite for the good news stories that Heidi's talking about?
Well, this is where, I'm a journalist. I've grown up as a journalist, but I also am a facilitator of everyone communicating. We just finished taping a set of 31-minute videos for me to explain how to write for the internet with impact. There's one on how to take pictures, one on photography, one on how to do public speaking. They're mostly for our grantees, the scientists who get grants, but they'll be ultimately for everyone. So my goal, like my one hashtag, if it could be like right here, is make reality cool again.
You can get a tattoo.
No, I'm not sure. No, because that would imply it's a permanent question.
Or a cap.
So, and it has to be cool. And this is
more practical.
But you really hit on one of the tough realities, which is human nature seems to attract us to the moment and to the clickable, scary thing, and then we move on. So we have this weird paradox inside us of being attracted to those polarizing, hard, scary things, and then we have status quo bias, which pulls us back to being boring, normal people. And how do you facilitate real change with those habits? I think it really goes down the chain to kids, and which is why here, what I saw that just now so excited me, was this group of elementary school students who were being unleashed on the floor with the posters, and and that I took a pic. I just put it on Instagram. I was like, yes, the more of that, the better. And by the way, again, in National Geographic, a huge push there is kids. Geo-inquiry is a hashtag for their push, and if we don't start early on, if we do start early on, I think we can start to build a sense of engagement.
Andy, thanks ever so much indeed for joining us. Really appreciate it, and keep up the good work. Thank you.
And you too.
Thank you.
My pleasure.
So let's start our daily tour of leading-edge scientific universities and institutions around the globe.
Marine environments are facing drastic changes in the future. To investigate the combined impact of climate change, natural variability, and human influences, the German Federal Ministry of Education and Research established the National Marine Research Program, MARA-N, Coastal, Marine, and Polar Research for Sustainability in 2016, under the umbrella of the Research for Sustainable Development Framework Program. With its 6 interdisciplinary topics and 2 cross-sectional activities, MARA-N addresses all aspects of marine research.
MARA-N is the basic funding framework program of our ministry to fund coastal, marine and polar research activities. We provide to our excellent scientists state-of-the-art research infrastructure For example, Germany has one of the most modern fleets for research vessels in the world. Institutional funding, as well as the project funding of marine research. And of course, our marine research activities are embedded in an international as well as European research agenda.
MARA-N research will support the implementation of both EU directives and the UN's 2030 Agenda for Sustainable Development. To deliver solutions for politics and society to protect and sustainably use our oceans in the future, the program supports several national and international marine research efforts, including the Regional Atlantic Circulation and Global Change Program, RACE.
Under global warming, the Atlantic circulation will change severely, and it will have grave impacts on the climate system and also on sea level in Western Europe, but also in North America. RACE maintains 5 long-term transport time series in key regions of the Atlantic circulation, and these enabled us for the first time to quantify the mean of the circulation. But we also found out that there is a large variability from days to even several years, which were unknown so far. We could also illuminate the vast progress which has been made in the realistic simulation of the Atlantic circulation. In typical climate models, this freshwater invading in the key region determines the strength of the Atlantic circulation. But in the Viking model, most of this freshwater stays in the boundary current around this key region, and only later into a very small fraction invades in the key region.
The Viking simulation was recently confirmed by observations measuring fresh water in the Labrador Sea. In addition to ocean research, MARA-N also supports studies into the impact of human and natural forces on our coastal regions, including the development of new protective measures for coasts worldwide.
The research programs by BMBF not just focus on fundamental research, but applied research. So what are the effects of waves and tidal currents on marine infrastructure, sediment entrainment and transport in coastal environments, ecosystem services of plants like salt marshes or seagrass meadows for the level of protection of coastlines. We deal with capacity building efforts that say the experiences and also technologies from Germany can be implemented in developing countries in order to sustain their future. We focused on the city of Padang that is on the shores of Sumatra. We looked into tsunami inundation and contrasted this, how the city needs to be evacuated due to an, say, incoming tsunami that will hit the city of Padang within 50 to 20 minutes.
Coastal dynamics are not only studied in temperate and tropical regions, but also in the Arctic, one of the least studied areas on Earth, including the impact of permafrost thaw on coastal Arctic waters. The permafrost thaw impacts the global climate and the Arctic Ocean. In September 2019, Mosaic, the largest Central Arctic expedition in the world, will be launched.
The Arctic region is one of the fastest warming regions of Earth. The losses of sea ice that we observe is not well predicted, not well described by our current Earth system models. And we suspect that the lack of observation, the lack of knowledge about the Arctic winter is a key problem. The Mosaic expedition is about setting up a multidisciplinary observatory for the study of Arctic climate. It means that we will freeze in our icebreaker Polarstern for a year to drift along with the sea ice across the North Pole. And we will host 600 scientists from 17 different countries to carry out studies about how the winter influences Arctic climate. And it's also a big logistical challenge. We need to make sure that 600 people are exchanged throughout the year. We need a runway on the ever-thinning sea ice. We need to provide fuel and food all of the time. And we need to make sure that everyone comes home safe.
Thanks to the hundreds of researchers involved in MARA-N studies and the vast amount of data collected, marine research in Germany will make a vital contribution to the discourse on our ocean's future with policymakers and the public around the globe.
In 2016, we started an open dialogue involving all the stakeholders, scientists, the representatives of civil organizations, business people, as well as governmental experts. And by this open dialogue, we tried to identify research fields relevant to all these stakeholders, but as well systemic solutions to the challenge of sustainable polar and marine research. Germany is very proud to support the United Nations Decade of Ocean Science for Sustainable Development from 2021 to 2030, and we are very proud to host the kick-off event in Germany.
The problem that scientists have had for a long time in the geosciences domain is gathering our information, sharing our information, and using it with each other in a way that was easy and maintained all the fidelity, all the information about the data. EarthCube was established in part as a way to help streamline the process for working scientists to acquire data, but also to help us look for relationships between different kinds of observations from different what we call science domains to better understand how nature works.
EarthCube is all about getting together three primary groups of domain scientists, computer scientists, and also the data people, data managers and data scientists.
The vision I like to use is equivalent to one of these home devices that I can speak to. For instance, I'd like to say, ooh, how do erupting volcanoes in this part of the world affect climate in that part of the world? And maybe no one's asked that question before, but by having access to all that information in a way that's interoperable, we can start to look for those sorts of relationships to understand if that question even has any meaning.
I love volcanoes. I study the East Africa Rift System. A part of my job is installing a volcano observatory there. So for us, we've partnered with an EarthCube project called CORDS. CORDS is the cloud-hosted real-time data for the geosciences. So we use this cyber tool, and what it does is all of the brunt work for us. It's able to take a data stream that's coming in from Tanzania, properly search the stream for the information that we require as geodesists, and then give us that information in a way that we can actually do something with it. So in CORD's case, that would be automatic plotting and or automatic downloads.
These tools are allowing us to access data and work with it in ways that we wouldn't have been able to do as easily before. And I'm seeing a shift in these early career researchers, that they're becoming a lot more open to the next level of cyber infrastructure. And I think EarthCube represents one aspect of the next level of cyber infrastructure for geosciences.
Another really interesting application is an application called Flyover Country.
Flyover Country brings information about the landscapes around you to your phone, no matter if you have a connection or not. So it can be while you're flying in an airplane, looking at the airplane window, or on a road trip, driving along, or on a hike up in the mountains. You can pull up information about the landscape sourced from many different geoscience databases and have some access to what scientists have learned about the landscape that you're currently encountering. That EarthCube concept of making data accessible and available easily in formats that allow people to work with it made it actually possible to make an app like that.
EarthCube's commitment to making all of its code and software open source is very exciting. EarthCube is also adopting FAIR data principles, making data findable, accessible, interoperable, and reusable. And data sharing means that you get new collaborators, and it means that your work goes further than it would before, and it means that the study that you did can be reused in a larger context in many other places. So that means a lot for the future of science and the future of collaboration.
That's where I see the future of geosciences data going. People sharing when they publish their data, not just the paper, not just the data that goes with the paper, but the workflow that got to the place of analysis that you're publishing.
EarthCube is part of a data revolution and a cyber infrastructure revolution that is happening in our discipline to provide the rest of the geosciences community infrastructure and a roadmap for optimization of all of the work that we do and how we conduct our research into the future, how we record our research, and how we present it to other people.
This EarthCube community, I would say, is really more to sound very sappy, a family, you know, where people are spread out over different universities, different research consortiums, and they are working together to share science.
I think the communication of science is like one of the ultimate goals of it is to bring the knowledge of the ways, the wonderful stories of the ways that the world has come to be, that the way it is, to people.
EarthCube is a realization of a dream, the dream to take the latest cutting-edge technology and apply it to science workflows for meaningful results.
Rapid decrease in Arctic snow and ice and significant environmental changes are the most drastic evidence of global warming. Better understanding of the status and trend and causes of Arctic environmental changes and accurate future prediction are very important, not only for Arctic but also global climate issues. JAMSTEC have been conducting the Arctic research since early 1990s. Then, with accumulating our experience for the Arctic research and also in the context of growing social interest of Arctic issues, JAMSTEC established the Institute of Arctic Climate and Environmental Research, so-called IACE, on April 1st, 2015. We are now investigating Arctic environmental changes using research vessel Mirai, Earth simulator, and other facilities. Research vessel Mirai has been conducting the Arctic Ocean observation cruise almost every year since 1998. Our research target is mainly in sea ice reduction area to understand what kind of changes and impacts can be found after sea ice retreating land. We found that due to global warming and sea ice reduction, the Arctic Ocean is warming, freshening, and changing more active. Also, it was a very cold and quiet ocean with sea ice cover. We also understand that, especially in the Pacific sector of the Arctic Ocean, influence of Pacific water inflow through the Bering Strait are very important from not only physical and chemical, but also biological points of view. To evaluate the impact of the Arctic environmental stressors on marine organisms and ecosystems in lower trophic level, we have conducted field observation, plankton culture experiment, and development of numerical modeling. Ocean acidification is proceeding in the Arctic with the fastest rate of the world due to sea ice reduction and increase in freshwater input. Micro X-ray computer tomography technique is one of the useful methods for ocean acidification research. Using this technique and collected samples from the Arctic Ocean, we can evaluate the change of carbonate shell density of plankton foraminifera and theropod dwelling under the condition of ongoing ocean acidification. In this research unit, we also started collaboration with ocean policy experts for further research on marine ecosystems and educational outreach activities. Temperatures have been increasing at higher rate in the northern high latitudes, especially over the land area. This can greatly alter the atmosphere and the terrestrial surface environment, such as permafrost degradation, wildfire, and greenhouse gas emissions from boreal forest ecosystems. We are trying to understand the impact of Arctic warming in a long-term flagship observing site in interior Alaska. The vertical turbulent greenhouse gas fluxes between the atmosphere and the surface are measured by the eddy covariance method. We are also measuring and modeling the black carbon emission, transport, and deposition. They are also an important topic for the understanding of the role of black carbon to climate feedbacks.
Our group performed numerical experiments in order to elucidate how the Arctic and polar extrapolar interaction will be under the global climate change. Facilities such as the supercomputer, the Earth simulator, support our research activities. In our recent study, for instance, we've shown that the reproducibility of warm water transport into the Barents Sea from the North Atlantic is essential to predict the wintertime sea ice condition up to 11 months ahead in the Barents Sea and eventually in the whole Arctic Ocean.
There are lots of knowledge gaps concerning the sea ice of the Arctic Ocean, such as the sea ice thickness, sea ice dynamics, and sea ice-ocean interactions. Therefore, Geographic is now developing a special platform that will be moved under the sea ice and measure the various kinds of data continuously and automatically. It's like an intelligent underwater drone for the Arctic Ocean. Now, we've already designed and have started building a prototype. In the near future, we believe that underwater drones will collect invaluable data under the sea ice.
Thinking of future prediction about Arctic and global environmental changes, there are still many uncertainties. Therefore, we need to improve our understanding for reduction of such uncertainties. We need to collect accurate and comprehensive data, for instance in the sea ice region, permafrost area, and other data insufficient area in the Arctic. Such data and new knowledge can correct our misunderstanding of important processes for the Arctic region and support development of more accurate climate model for future prediction. Based on our results, we continue to provide useful data and knowledge regarding Arctic environmental changes toward not only scientists but also stakeholders who are interested in Arctic and global climate issues.
The 21st century is the century of ocean. However, ocean exploration and development is characterized by high technology, high risk, and high investment.
How to integrate the multi-channel information and how to coordinate multi-institutional infrastructure are the major challenges in ocean and climate science right now.
更需要我们全世界的科学家联合起来，共同协同攻关，共同来认识海洋，来开发海洋，让海洋为人类造福。
The establishment of Marine National Lab was approved by China's Ministry of Science and Technology in 2013. Our national lab is in the best position to pursue synergy for ocean research through gathering resources at home and abroad. Qingdao National Laboratory for Marine Science and Technology focuses on advancing both fundamental and cutting-edge research by integrating resources and talent, forging partnership, and sharing major facilities worldwide. QNM is designed to cover nearly all marine disciplines. We have been working on issues such as ocean observation, resource utilization, and marine ecological environmental protection. To pursue solutions to those global challenges, we are leveraging the state-of-the-art technologies to support relevant research. QNM activity promotes the construction of the third ocean drilling vessel in the world, with the aim to break through the Earth's crust and enter the mantle. High Performance Computing Center provides technological support of computing science, artificial intelligence, and big data. QNM sets 4 types of research units: functional labs focusing on fundamental research, joint labs focusing on technologies, open studios invite teams worldwide to conduct projects, and overseas research centers for collaborative research.
We integrate resources and professional team all over China to conduct the research. The laboratory for marine mineral resource focus on 4 research fields: marine gas hydrate, oil and gas, solid minerals, and key technology for marine mineral detection. Our lab established this technical system for the gas hydrate in the water for the first time in 2017. Results has played an important role in the gas hydrate production test in China.
The functional laboratory for ocean and climate dynamics focuses on the structure, dynamics, and variability of oceanic processes in the coastal seas, the open and deep oceans associated with climate change and environmental change. For example, the temperature salinity, circulation, response, and feedback to climate variation in the China Seas and the Western Pacific. Interdisciplinary and collaborative research is essential in this lab, since the scientific issues associated with climate change are so complicated and comprehensive.
We aim to build high-resolution Earth system model to simulate the environmental changes over the past 25,000 years with Light of Taihu supercomputer through cross-disciplinary collaboration. The Infrastructure and Innovation Center for Marine Drug Screening and Evaluation in QLM has united over 20 research teams from 5 countries including China, US, UK, France, and Spain. This is the first time in the world to screen active drug molecules in such a large scale. Qingdao is home to 30% of China's marine institutions, as well as 50% of its marine talents.
青岛海洋科学技术国家实验室位于中国青岛蓝谷黄海之滨。青岛蓝谷是一个以海洋为特色的高科技研发和高技术产业的聚集区。为了实现这个目标，我们集聚了中国最顶尖的海洋科技创新平台海洋国家实验室，也集聚了一批科研院所和产业，这样的话打造了一个产学研相辅相成的一个创新生态体系。包括我们国外的科学家到这儿来跟国家实验室合作。
QNM has established a number of open infrastructures for marine research. Scientists worldwide can access such infrastructures as the world's fastest supercomputing center in marine field and the research vessel fleet to support their research. We highly value international collaboration. To facilitate a cooperation among the global marine community, we have held 2 rounds of Global Ocean Summit, gathering over 200 leaders of top marine institutions worldwide. To gather top scientists and engineers worldwide, we launched the Ocean Talent Program to provide the most enabling research environment for scientists. We are establishing overseas research centers with the world's best marine institutes, working with Australia's CSIRO. We launched the International Center for Southern Hemisphere Ocean Research. I'm looking forward to world-leading integrated marine research center to tackle the most pressing global challenges and conducting cutting-edge research for the benefit of humanity.
We're here in the exhibit hall at the NASA booth. They have quite a footprint at this fall meeting and so many exciting things going on. Come on, check it out.
This year, NASA has a huge exhibit space and to accommodate a lot of exciting programs that we put together.
Here we are at the NASA booth, and for the James Webb Space Telescope, we have a virtual reality experience. It's part of our outreach program, but you can fly to all the different planets in the solar system. You can explore James Webb in 3D full size at the second Lagrange point. You can throw stars into a black hole. And my personal favorite, you can fly through a galaxy. So it's like skipping stones on a pond, but you can fly through a galaxy.
We're here with the Hyperwall, which is the centerpiece of the NASA exhibit. And the Hyperwall is a very high-resolution 6K visualization system that we use to showcase all sorts of NASA data from all the science disciplines within NASA. So Earth science, planetary science, heliophysics, astrophysics. And of course, AGU has a heavy planetary and Earth science focus, so a lot of our presentations are focused on the Earth and planetary sciences. And we always have great attendance at our Hyperwall talks, and we look forward to coming to AGU every year.
With the changing climate, the Mediterranean regions will undergo an increase of all kinds of extreme events, such as intense rainfall, heat waves, and rising sea levels. The Sahelian region are already affected by the consequences of the change of climate that affects soil erosions, impact on agricultural resources, drought and floods. Understanding how the environment is changing can help to find mitigated solutions for people. Hydrosciences Montpellier was founded in 1998, resulting from the merging of researchers from Montpellier University, CNRS, and from IRD. The main objective of Hydrosciences Montpellier is to quantify and predict how climate change and human activities affect water resources, mainly in the Mediterranean and tropical regions.
At Hydrosciences, we are conducting interdisciplinary research to investigate the impact of mining activities on metal contamination. We combine different chemical methods, including the analysis of metal concentration, speciation, and metal isotope ratio. Our results on the Gardon River illustrate how historic mines still contribute half a century after the closure to metal enrichment in the downstream watershed. In the mining city of Oruro, with Bolivian researchers, we highlighted the human exposure to various toxic elements such as lead, arsenic, and antimony, and we demonstrated that children were especially at risk.
In the Mediterranean region, the water demand is more and more important. Karstic aquifer may represent an important water resource for the population. The Lez Spring is the main outlet of the Lez karstic system, which supplies the city of Montpellier for water. We created the Médicis Observatory in order to characterize hydrogeological behavior in this aquifer. We work together in our Hydrosciences laboratory with hydrologists, hydrogeologists, chemists, microbiologists in order to characterize the Lez aquifer vulnerability.
Africa will lead global population growth. So preserve your water resource to ensure access to safe drinking water is the most important issue. Our billion population face difficulty in our water supply. The fresh water Agen Logon near Abidjan can be used for drinking water. Since 2050, we quantify the water flowing into and out of the Agen Logon, and we characterize the water quality in terms of nutrients. We hope that the challenge of water for the city will become the major African hydrological study.
All Mediterranean countries are affected by floods and flash floods, and this is a main natural hazard in this region. At the Hydrosciences Montpellier laboratory, we work on the topic of extreme events, starting from the precipitation to the hydrological modeling of natural watersheds, but also hydraulic modeling for urban areas. The models that we are developing are used to represent the natural processes and then they can also be used to make future projections. There is an ongoing initiative to update the hydrological norms, in particular in West Africa, to take into account the effects of climate change. These norms are used, for example, to design reservoirs, dams or roads.
Large rivers in Africa, like Congo River or Niger River, are a very good example of the impact of climate change because those rivers are very poorly equipped by dams and other management structures. We found a major result in the Sahel with an increasing runoff when rainfall are decreasing, which is called the Sahelian paradox. In tropical Africa, we found a decrease of groundwater reserves, which is dramatic. And in North Africa, the dams prevent many of the sediment to reach the sea, which has coastal impacts with economic issues in this area.
West Africa is a region in fast transition from the point of view of climate, demography, land use. So it is crucial to understand the underlying processes driving the water cycle. The Amakach Observatory has been set up in 4 countries over West Africa, in Mali, Senegal, Benin and Niger. The observatory is made of networks of sensors deployed into 4 countries, which document the ecoclimatic gradient across the region, from the local scale, around 100 meters, to the mesoscale, some 10,000 square kilometers. We can use the Amakach networks to build and validate models that can be used for adaptation and mitigation strategies for those developing countries.
HSM is deeply involved in sustainable development related to water resources, water quality and health. It is also concerned by training younger generation of researchers to build a common future for green water. HSM works with partners in developing countries. They are involved with us in building sustainable structured resources like joint international research laboratories to have a vision on the future research and development with partnership and international programs.
This is the Department of Earth and Environmental Sciences at Rutgers University in Newark. It's an urban campus. We attract a lot of students from urban areas, and we really make it a mission of this department to help attract these students and help them to thrive in the geosciences. We have 9 faculty members, 8 TAs, 70 undergraduate majors. We probably have about 25 to 30 graduate students.
I attended Rutgers University here in Newark, and now I'm working in the environmental industry as an engineer. The courses I took in the major I was here, it really prepared me for all the field work. We did go out and observe rock outcrops. The writing absolutely prepared me for it. All the reports I write, and just being able to understand the natural world.
I love it. The geology department is so supportive. Dr. Mihaela, she really helps me. Like, she's teaching me SEM right now. They really focus mainly on undergrads and helping them understand the instruments and actually understand geology itself.
The department kind of focuses on 3 specialized areas. We look at pollution of air, water, and soil. Okay, and so one of the parts of that is geophysics, and these are environmental geophysics that look at just the shallow subsurface using remote methods to be able to see what's underground without having to dig a hole. The next part is to look at chemical pollution. So they're geochemists. They work with air, water, and soil pollution. And then finally, we have some geobiologists who work with microorganisms and how they deal with the polluted environment.
I'm interested in the preservation of biosignatures in carbonate rock. So I'm currently looking at stromatolites from both Morocco and locally in New Jersey. The main goal of the research is to see if we can determine if there's a texture of a rock or a chemical signature that may indicate life or a biosignature preservation.
Mihaela Glamaklia is an assistant professor in this department, and she works on very interesting stuff where they look at extremophiles, things that can live in extreme environments, and right now she is modeling how life began on Mars.
Our field areas that we are studying are usually used as terrestrial analogs to other planetary bodies. So the most frequently we are looking at systems on Earth that resemble in some way systems on Mars. And we want to provide space missions with technological and scientific framework within which they can do research on other planets and specifically detect life on other planets.
Dr. Adam Kuska is in oceanography, geobiology. So he looks at bigger scale pictures, global scale of microorganisms and how they are impacting with global climate change.
I work on marine phytoplankton. Marine phytoplankton are very important for fixing carbon dioxide. They fix about half of the carbon dioxide on an annual basis, with land plants doing the other half. It seems that marine phytoplankton are iron limited in vast regions of the ocean. Our lab strives to understand how different marine phytoplankton or marine algae compete with one another for iron. One recent development in our lab, which stems from a collaboration with our colleagues at the Craig Venner Institute in California, we unraveled a novel mechanism of iron uptake in algae that seems to resemble the uptake pathway in human blood cells.
We had a really exciting addition to the department just recently. And what we did was we obtained the Meadowlands Environmental Research Institute. And this is a field research lab that sits out in the middle of the Hackensack Meadowlands. Overlooks New York City. You see the New York City skyline in the distance, and yet the area looks pristine around it. Now it isn't. It's highly polluted underneath, but on the surface, it looks like a beautiful place to go.
Here we create the professional and the scientist who's going to be working in the front line of the pollution and mitigating this pollution and understanding the challenges and figuring a way around, global warming and sea level rise in these low-lying areas. A lot of the contamination is below ground, 30, 40 feet sometimes. In order for us to get down and understand what's going on and how much of the contaminant is down there, we have this drilling machine. So we can make holes up to 100 feet down. And we can take samples or monitor, what's going on with the water and the soil interface down there. That's why this is so important to have access to, deep into the soil.
At Rutgers Newark, this area, there's a lot of opportunities for using these geophysical techniques to address critical environmental problems. For example, in these wetland systems I've been working on, I've worked in very pristine systems in Maine, which are very different from what you see here, where we've focused more on understanding the hydrology of these systems and also the release of methane gases to the atmosphere. And we've made pretty profound discoveries using these geophysical techniques.
The biggest challenges that the world is going to face over the next couple of decades are going to be in the environment, whether it's climate change or pollution or global changes, and we want to be at cutting edge in that. Not only do we want the research to be able to predict what's going to happen and try to remediate things before they become really disasters, but we also want to make a very strong, educated workforce that can really address these issues.
Climate change is definitely the greatest threat that our forests have ever faced.
Climate is interacting with existing stressors and exacerbating them in a lot of ways. Sometimes you see that out west, for example, big fires or big pest outbreaks, and it's very dramatic, even lethal.
In California, we've seen 130 million trees that have died just since 2010.
In other places, it's a slower change in which you just don't get the reproduction in the forest that you used to, and the competitive relationships between different species in the forest are changing. And so the forests that we know are not going to be the forests that are there even decades from now.
The key to pre-storing our forests for a changing climate is science. Science is our crystal ball for looking into the future and understanding the conditions that our forests are going to need to survive in decades into the future. So that's one of the reasons why American Forest is so excited about working with the Northern Institute of Applied Climate Science. They're sort of like our crystal ball for understanding these scientific changes and helping us and our partners to think about how to use that science to adjust the way that we care for forests into the future.
NIAC staff use a process that involves investing a lot of time, building relationships with individuals, with groups, with all kinds of stakeholders, and asking those stakeholders what they need.
One of the ways that we help organizations pursue climate adaptation planning is through a process that we created with lots of partners called the Adaptation Workbook. And a critical part of any adaptation is to understand what it is that they value, what it is that they want, what it is that they need to do, and then ultimately use that to ground the entire conversation, to ground all of the planning, so that they're always coming back to what is it that they are most valuing in this forest.
I'm Rachel McDonald. I'm the forester for Keweenaw Indian community. I help to manage Lance Indian Reservation, which is about 66,000 acres altogether, but the tribe owns and actively manages about 18,000. Climate change poses a threat for reducing the winter weather window. We've seen a reduction of the time that we have frozen soils, which really creates a problem when you want to get heavy equipment into the woods to harvest timber.
The Keweenaw Indian community is really interested in a wide variety of different values associated with their land. So we go through the adaptation workbook, which breaks down this overwhelming issue of climate change and helps deal with it in smaller pieces of information, smaller chunks, so that way we can think about how is the particular place vulnerable to climate change, how might the tree species or ecosystems change, how does that affect the management that they're doing, and then what ultimately can they do to help enable their ecosystems to be better adapted to future conditions.
Climate change, it's such a huge issue that previously I didn't know where to start. Going to their workshop really made me have to stop and learn how to integrate climate change into my decision making. We've had to be creative, working with NIACs to track our equipment operable days in the winter, and being careful and cognizant about protecting more sensitive areas in the summer so that we could have timber harvests in non-winter periods.
Our work at NIACs is really intended to help bring the best science that's out there into the hands of managers rather than just having it be stuck in journals and in places where people can't access it. We want to be able to bring it out to light and get it into the hands so that people can make better informed decisions.
NIACs is also a great partner in working with policymakers, something that's very important to American forests, to translate complicated scientific principles into easily understandable guidance and direction for what to do is just as valuable for policymakers as it is for forestry practitioners in the field.
American Forest sees itself as a movement builder and a movement leader. We can't do what needs to happen for our forests alone. We need to be working across the sector, and we do that through collaboration and through coalitions.
Like the Forest Climate Working Group and our work with the United States Climate Alliance. Through these coalitions and partnerships, we're using tools developed by NIACs and other partners to help create a new movement for climate-informed forestry across America.
Certainly American Forest is one of those organizations that are at the forefront of thinking, how do we pursue forest restoration in a climate-informed way? How do we design pro-forest policies that themselves are climate-informed and that can help ensure that our forests continue to sequester carbon and help slow down the accumulation of greenhouse gases in our atmosphere. And we are ecstatic to work with them. The people that we serve, that I get to interact with on a day-to-day basis, they are absolutely dedicated to being good stewards of the ecosystems that they manage. And when we help them to be more effective in their jobs, how can you not love that?
Well, what a pleasure. We're joined now by Chris McEntee, who, as you know, is the Executive Director of AGU. Chris, welcome.
Welcome. It's great to have you here at AGU.
Thank you very much indeed. Now, over 28,000 people here, that's a success, isn't it?
Well, the meeting here with over 28,000 has really been a tremendous success for us. All you have to do is keep walking around the halls, even at day 4 here, and you can feel the passion and the energy and the excitement about science and all that science can bring to society.
So I know this is a really unfair question, but of all these days, of all these people, of all these sessions, tell me what some of your highlights would have been.
Well, it's always difficult to talk about highlights at a meeting that's so jam-packed from 6 in the morning till 10 or 11 at night with a variety of different sessions. I think one highlight for me is the breadth and depth of different types of science being presented here from all parts of the world, but also the fact that we're growing in our opportunity to connect art and science and human health and geoscience and societal communications and training and outreach to policymakers with science. And so we're creating a whole ecosystem, really, where anyone who is a scientist themselves or an enthusiast about science or has different ways of expressing science can all come together and work together to achieve a common goal.
So you spoke a bit about the many disciplines and sort of we're weaving in more disciplines into the AGU meeting. I've been attending for over 10 years now and have seen that evolution myself as an early career scientist. But can you tell us a little bit more about AGU's efforts to bring more people to the conference, but really thinking about diversity? So not just diversity of disciplines, but who is welcome to the meeting, how it is that different people are getting information and feeling welcomed into this space and this community that is ever growing.
Yeah, well, AGU's always had a strong value about diversity and inclusion. It's really only in the last several years, though, that I think we've really embraced what was there, but had to have opportunities to express itself and be involved. So there's a lot of work being done by our art and science community here to connect visual arts and audio arts and musical arts with the scientific community. Well, they're scientists themselves, but they like to express it through arts, and so I think that's one way. We are fully embracing with our new sections, our education community and our geohealth community, and what's really interesting about both of those, particularly in geohealth, is that we've learned half the presenters in our geohealth sessions this year have never been to an AGU meeting before. We're trying to do a lot of outreach to bring in underrepresented groups. In fact, just walking over here, I was so excited. I saw a school group and they were lining up and they were full of energy, and their teachers were trying to get them all excited, and I go, "Where are you going?" They go, "We're going to the poster hall first."
Good luck.
And I thought, these are future geoscientists, or art and
Right.
science, or human health, or whatever they're bringing together. And of course, we're trying to make the meeting accessible for those who can't be here through a revamped AGU Go, and then having that available on demand. This TV program is also helping to increase accessibility. The press is welcome, and we're seeing also community leaders come through our Thriving Earth Exchange.
Fantastic. And so we have new disciplines. We've got these new groups, geohealth and education. As I understand it, AGU also has a new building, and one that you've been welcoming membership into, hosting events in, and also welcoming the press to. How does it feel to welcome the community to this new exciting building?
Well, the building is a renovated building. We've had this building as our headquarters for a long time, but when the building actually needed to be renovated and updated, we made a very, very forward-looking decision that since we are the organization that values community, that says we have to tackle climate change that wants to create a welcoming space and an educational space. We made a decision to do a very bold renovation. The building will be the first net zero commercial renovation in the District of Columbia. It has some innovative technologies that have been used outside the U.S., but are now being done for the first time inside the United States. It'll be a living laboratory. All the data we collect on water, air quality inside the building, on energy will be publicly available and for use by the research community. But it also is going to be a better place for our members and scientists. We have a new conference space. We have an Earth and Space Science exhibit. And it's going to be a really healthy and productive workplace for our staff. It was very, very exciting to have an opportunity to give people sneak peeks at it while we're here, but when we hope that people will continue to come back, whether they're coming to have a meeting, but also if they just want to drop in and say hello and learn about Earth and space science.
Great. So hopefully next year we'll see some posters and oral presentations from those data that are being collected.
That's the goal, is to have some data and oral presentations. We've already been invited to speak at many conferences, including the International Green Build Conference. Green Build is the organization that has advanced the LEED rating system for buildings, and there's quite interest. And buildings are one of the largest consumers of carbon types of energy, carbon-intensive energies, and so we really think this will be a very important step in accelerating the building industry to contribute to reducing carbons and reducing the environmental imprint that we all have on this planet.
So Chris, final question from us. This meeting also kicks off the centennial, doesn't it? So what else are we looking forward to in 2019?
Well, AGU will celebrate a centennial in 2019. The first thing I want to say is I want to invite everybody to come tomorrow to our session on Friday. It's going to be a very interesting and exciting session where there'll be very short talks across all of the Earth and space science disciplines about the great achievements and what's ahead in Earth and space science. I think what I'm most looking forward to in 2019, even though we have a variety of programs, is two things. One is the opportunity for scientists and enthusiasts all around the world to celebrate and engage locally where they are. Because we have grants to help them, we have tools and resources to help them. We're already seeing some taking action, and we hope that just inspires more and can be something we can build upon after 2019. I think the second thing is, and it's Giving Thursday, and I hope everyone will stretch a little bit of their extra dollars and put money in the little collection baskets that are around, but also write a check, fill out their credit card, because we have an opportunity to raise $2 million to provide travel grants for 80 more students to be able to come to this meeting. Our members consistently tell us that when they come here as a student, it inspires them and so excites them that they can't wait to go back and advance science. And we have so many that want to come, particularly from underdeveloped areas or underprivileged types of situations where their financial circumstances don't allow them to come. And by successfully raising this money, we'll be able to bring 80 to 90 more to this setting and help experience it. So, stretch a little bit. Think about it. If everybody just gave a cup of coffee worth of dollars every day while they're here, we would really be a long way towards raising those dollars.
Well, Chris, thanks ever so much indeed for joining. It's been a real pleasure to talk to you, and thank you.
Thank you very much, and go AGU in 2019.
Thank you.
Thank you.
When EarthScope was started, some of the key goals were really to map out the structure of North America, the continent, and the mantle beneath it, and really look at its properties, temperature, and ultimately its strength. EarthScope has now at this point kind of blanketed Alaska and the rest of the lower 48 with seismic and geodetic instruments. So it's been an incredible tool for discovery. We've seen things that we never even knew we were looking for.
From the very beginning, the National Science Foundation recognized that EarthScope's potential to make big advances in the field of earth sciences, primarily because the instrumentation would be very densely spaced and would be widely distributed across the entire North American continent.
EarthScope is like a telescope looking down inside the Earth. And it used three main kinds of tools. There was a seismic network or seismic array called US Array. And this basically rolled across the continent and is currently deployed up in Alaska. And the idea of that was to actually make images of what's inside the Earth.
The US Array helped us to be able to image the whole continent in a way that we hadn't been able to before. That a good example of this would be the thickness of the crust that we live on. We were also able to look even deeper down underneath the continent and see the trail of a dead plate that had been shoved underneath millions of years ago, coming in from the western part of the US and now buried under the central and eastern part of the US.
The San Andreas Fault Observatory at depth is about a 3-kilometer long borehole into the San Andreas Fault over a segment that it creeps, so it doesn't generate large magnitude earthquakes, but it just moves slowly, or what we call aseismically. The goal being to drill through the fault, to instrument it, to collect samples, and to just observe all we could about the fault zone. We've really shown that the San Andreas Fault, its intrinsic properties are very weak here. Previously been debate over whether it was a weak or strong fault, whether it slipped aseismically because of pressure along the fault zone or if it was just the actual material properties. And SAFOD, with sampling of the core and being able to do laboratory measurements on it, really showed that this is really weak material.
PBO, or Plate Boundary Observatory, is a network of over 1,000 really sensitive GPS antennas that are mounted to bedrock throughout the United States.
The Plate Boundary Observatory, which is a geodetic network, so using high-precision GPS instruments to measure the active deformation of the continent. So that would be tectonics, just the plate tectonic deformation. That would be earthquakes. And it turns out there are also other kinds of slip that happen on faults. Earthquakes are fast slip. There are these kinds of slow slip. And we can measure that with the Plate Boundary Observatory. And so this gave us great tools for looking at both the structure and the dynamics of the continent.
One of the cool things to result from the project is this new field called hydrogeodesy. Hydrogeodesy is using GPS signals to infer information about the Earth's hydrologic cycle. So you can do things like measure groundwater, soil moisture, snowpack, or even tidal level with GPS data. The data from the PBO have been used for a variety of different things, from understanding the evolution of the recent California drought to quantifying how much water was dumped in Texas during Hurricane Harvey. The data from the PBO network are going to continue to be useful for many years.
There's two ways that people can easily have access to what science and educational activities have come out of EarthScope. If people go to the EarthScope website, they can look at the Science Nugget map, and the map shows different links to descriptions of different projects that have been funded because of EarthScope. Additionally, there's an app called Flyover Country that people can download to their phones, and when they're traveling on an airplane, they can look at the app and learn about different EarthScope discoveries, and it's available offline and online, so there's no trouble when people are up in the air and they don't have Wi-Fi access.
EarthScope also encouraged people from different disciplines to work together. The fact that we had all of this data and this geographic scope really encouraged people to bring together information from multiple sources in a way that doesn't always happen naturally.
EarthScope has been enormously successful. I see the legacy as really having 4 parts. The first part is the science that was able to be done that we otherwise wouldn't have been able to accomplish without EarthScope. The second part of the legacy is the data. A lot of different seismic, geodetic data were recorded as a result of EarthScope, and that data will be available forever. The third part is the instrumentation. A lot of instrumentation was installed across the United States through EarthScope, and much of that instrumentation has been adopted by other federal, state, and local agencies. And then fourth, the people of EarthScope. A whole generation of scientists were educated as a result of EarthScope, and they are now scientists and making their own contributions to the field of earth sciences.
CIDER stands for Cooperative Institute for Dynamic Earth Research. So CIDER is a collaborative institute without walls, which brings together solid earth geoscientists across generations and across disciplines in order to together help improve our understanding of the Earth's present dynamics and its past history. One of the centerpieces of CIDER is a summer program which lasts 4 to 6 weeks and consists of one part which is a tutorial part for graduate students and postdocs, and then followed by 2 weeks in which the students get together in groups with faculty, with more senior scientists, to start doing research on some multidisciplinary topics that have been defined during the 2 weeks of lectures.
Certainly one of the issues that CIDER accomplishes is in fact defining major challenges that require a variety of disciplines to contribute to. And so, each of us in our own way will contribute to problems within the spheres of our own influence and expertise. And what CIDER does is it puts together a variety of different people with different perspectives, different points of view and different understandings to really identify what are the major stumbling blocks, obstacles for making progress on important questions, and then really help sharpen and focus the problems that we're actually trying to solve.
I think the tools people develop at CIDER are two types. One is some level of self-confidence that even though something is not in your field, it's approachable and understandable, and that you're comfortable with reaching out to people in those fields and engaging in a discussion and some research. The second thing is a deeper appreciation about your own science, that by explaining it to people in other fields and working with people in other fields, you learn to better understand what you do. Typically when we teach a class, there's a lecturer and then there's a group of students. At CIDER we have many people sitting in the room who have expertise in the same topic that is being discussed. And so that means there's an active and quite vibrant discussion about the material.
We conduct our summer programs either at KITP in Santa Barbara or at UC Berkeley.
So the KITP is the Kavli Institute for Theoretical Physics here at the campus of University of California, Santa Barbara. Our main goal is bringing scientists together from all over the world, about half of them from outside the US, for prolonged periods of interaction. So what CIDER has always been doing here every other summer for many years is bringing together researchers to then explain to younger graduate students the impact of what's happening within the field.
My first CIDER was in 2011 at UC Berkeley, and then I've participated 3 times since then. The last 2 times were here at UC Santa Barbara after I moved here as a faculty member. I think CIDER has been very influential in our community because it's focused on young scientists, it's focused on graduate students and postdocs primarily, and then senior participants such as myself come along to give lectures. But I have to say that I have learned so much attending CIDER because I learn about all the work that's being done in related disciplines that I might not follow in the literature. So CIDER is a great melting pot, really, because you have quite senior scientists, quite junior scientists. Hopefully it breaks down any barriers, any intimidation that junior scientists might feel in terms of talking to a senior colleague, because everybody's together. And I think it really succeeds quite well in opening up those lines of communication. CIDER's greatest legacy is that it has trained young scientists in how to do collaborative, cross-disciplinary research.
I can recognize a student who went to CIDER. They think differently, they work differently. They work across disciplines, they have international collaborations, and they're not shy to move in new research directions.
I think one of the great accomplishments of CIDER has been the training of really a generation of young scientists that are interested in pursuing interdisciplinary research. They're more comfortable with those ideas, they're more comfortable with crossing disciplinary boundaries to pursue important problems, and I think this has been probably one of the major outcomes of the CIDER program so far.
Hi, my name is Oded Aronson. I'm a professor and the director of the Center for Planetary Sciences here at the Weizmann Institute. The center brings together researchers from various aspects of planetary science. We have geochemistry, we have atmospheric dynamics, members of the center coming from all over the world to do research here. The center enables such collaborations by not only bringing together the relevant researchers, but also supporting them financially. And we're very proud to have this ability because it not only fosters new research here in Israel, but also enables us to have educational programs.
The center runs Israel's first graduate program in planetary science for both Israeli and international students wanting to gain expertise in research into exoplanets, paleoclimates, and the solar system.
We study other planets. Sometimes we do this by simulations in the lab, sometimes we have numerical models running on computers, and occasionally, when we're lucky, we even have spacecraft that reach these other worlds. One such spacecraft is called SpaceIL. SpaceIL is the first Israeli mission to the moon. The SpaceIL spacecraft will not only reach the moon and land on the moon, it will make measurements of the magnetic field of the moon and help reveal the origin of that magnetic field. The main goal of the SpaceIL project is to inspire and educate young people, both in Israel and throughout the world, about space, space science, and exploring space through planetary missions. I'm standing on top of the telescope observation tower on Weizmann's campus, and I wanted to take this opportunity not just to share with you the beautiful view of Weizmann's campus, but also to show you the moon, and to show you where it is that SpaceIL, the first Israeli spacecraft to the moon, where it is that we will land. We plan to land here on the Mare surfaces of the moon, and location in Mare Serenitatis, right between Apollo 15 and Apollo 17 on the boundary of the Mare.
The center also contributes to and receives data from international space missions with ESA and NASA.
For me, one of the most exciting aspects of the Center for Planetary Science is our involvement in international space missions, such as Juno and JUICE. My group studies atmospheric dynamics of planetary bodies in the solar system. We study dynamics on Earth, of course, on other terrestrial planets, and on giant planets. Giant planets have very deep atmospheres which extend deep into the interior, and we use various methods to study how deep they extend and what kind of dynamics we can find on these planets. As part of the Juno science team, we use very accurate gravity measurements that we receive from the spacecraft and use these to interpret the wind fields on the planet. Using this method, we've been able to determine the depth of Jupiter's atmosphere. The Jupiter Icy Moon Explorer, JUICE, is a European mission to the Jovian system. For JUICE, we're contributing an instrument built here in Israel that will allow us to measure very accurately the time it takes a radio beam to travel from Jupiter to Earth, and with that, we will be able to measure the properties of the atmosphere of Jupiter.
State-of-the-art facilities support research at the center, including the development of the Weizmann Fast Astronomical Survey Telescope, or WFAST, designed to observe the far reaches of our solar system.
The WFAST project is a project aimed at finding for the first time the yet unseen part of our own solar system, the Oort cloud, using two very wide field of view 57 centimeter telescopes to be located in Mitzpe Ramon, Israel, in the south of the Negev Desert. Each telescope will be capable of observing thousands of stars simultaneously and to look for the minute occultations due to the passages of small rocks in our own solar system in front of background stars. The Oort cloud was never seen before. If we will find it, we will be able for the first time to detect some of the oldest bodies in our solar system, characterize them, and to have some new clues regarding the formation of our planetary systems.
Experimental geochemistry is used at the center to simulate environments which either no longer exist, like early Earth and its oceans, or environments on different planets, like Mars, which are difficult to access.
We simulate those environments in the lab by controlling the temperature and the gas phase chemistry and the aqueous chemistry to try and understand the processes occurring in those environments. The climate and chemistry at a planet's surface are tightly coupled. The concentration of greenhouse gases in a planet's atmosphere controls the planet's climate and therefore its potential to host life. And we study these interactions. We study the ways in which the sources and sinks of various atmospheric compounds control the greenhouse effect on a planet and therefore its climate.
We're standing here in the cold room at the Weizmann Institute, where we simulate large-scale processes as they occur on Mars. In this chamber over here, we call this our Mars chamber, we can run experiments where we can study how water diffuses from the atmosphere through the regolith under Mars' atmospheric pressure and temperature and atmospheric composition down into the regolith to form the subsurface ice on Mars.
The Simulated Planetary Ices and Environments Laboratory contributes to my research in that it allows me to build and design my own experiments to study these fundamental processes. I chose to come to the Weizmann Institute of Science for a variety of reasons, but probably the most important factors were the large range of people that I could work with and their expertise, my access to state-of-the-art facilities, and also my ability to have autonomy in the science that I wanted to perform.
The center explores exoplanets, planets beyond our solar system, with the aim of gaining greater knowledge of their architecture and that of our own solar system.
Exoplanets are perhaps the most exciting intellectual discovery that humanity has made recently in astronomy. Here in the lab, we study specific aspects of exoplanets by looking at transit timing variations, looking at the passage of the planet in front of its host star and studying how those transits, how those occultations vary in time. This provides information on the size of the planet, but also on the masses of other planets in the system. We can study the system architecture and ask questions such as, is our own solar system unique or is it commonplace throughout the universe? What I really hope the center will do is continue to bring together researchers from throughout the world here to the Weizmann Institute to not only study the planets, but to also allow students to become expert in this discipline.
In the Arctic, you are faced with a harsh environment and a very sparse infrastructure. People living in the Arctic or working in the Arctic has to solutions which they can rely on. The Technical University of Denmark have a long history of presence in the Arctic. We try to bring together these Arctic researchers across these various institutes to create innovative solutions. We call it the Arctic Did You.
Our research involves development of technologies that fit the context of the Arctic. We're looking at the challenges that come from human inhabitation of the Arctic area. For example, for wastewater treatment, we have been developing UV treatment of wastewater for removal of bacteria and chemicals.
With the Arctic construction, people tend to think that it's the cold climate that's the big challenge. But it's the extreme climate more than cold climate. That's a real challenge in the Arctic. It's windy, it's raining, snowing. We're doing measurements on newer buildings in Greenland. We measure moisture and temperature and indoor climate so we can see what impact we have from different climatic conditions.
In the Arctic, you will have snow accumulated for a very long time. We are investigating snow accumulation through wind tunnel testing, so this is the first step. To verify our wind tunnel model, we have installed a cube in the city of Nuuk, where we observe and we measure the weather conditions. We can use the scaling laws we have then established to look at building shapes, at building arrangements, the influence of terrain.
Greenland is 100% dependent on fossil fuels. If we introduce renewables, this must survive the Arctic conditions. Our work here from DTU has been the driver for installing a wind turbine. This wind turbine is designed for extreme winds up to 65 meters per second.
The knowledge we do have here at the university impact everyday life of people living in the Arctic, but of course also the knowledge we have on climate change. We try to combine and coordinate research in the air, at the ground, and actually also at the sea.
25% of the northern hemisphere is affected by permafrost. Global permafrost has been warming over the past decade. Thawing permafrost results in a change in the mechanical properties of the soil, and that can result in damages to the infrastructure and buildings that are located in that area. DTU is part of an EU project called Dunatarjuk. This project looks at climate change impacts on Arctic coastal communities. We're looking at a community called Ilulisat to model the change in permafrost conditions over the coming decades for this particular community and to get an idea of how permafrost may change under different climate change scenarios.
My role in the EU project Renovated is to look at the fate of permafrost organic carbon in the sea. Where does the carbon go? Is it staying in its organic form, i.e. just being washed out and diluted in the world's ocean essentially? Or is it being turned into carbon dioxide by microbes in the sea? A lot of the work is about gathering water samples for us to find out what's where and what the conditions are. But we also carry out degradation experiments. How fast can microbes in seawater degrade this organic matter and turn it into CO2? We're also using this organic carbon as a tracer for ocean circulation and changes in ocean circulation.
It is very important that we understand the feedback mechanisms from the warmer climate, how much water is running out on the ice sheet and what is the volume of that. Eventually it ends up in the oceans and gives us around the world an increasing sea level. We use a lot of satellite information for measuring the sea ice extent, and we can monitor changes in it.
We are primarily working with the European Space Agency. They have a cryosphere satellite called Cryosat-2. Our prime work is to do validation of these satellite measurements by using airborne measurements. We are getting a higher resolution when we are closer to the ground. We are flying in about 300 meters above the surface, so we get some real accurate measurements.
We also need some information on land, so we have put up GPS stations where we can monitor changes in the bedrock, in the height. When we have less ice sheet, less mass, then it will actually increase. Finally, we use measurements from the gravity field mission GRACE, where we can actually determine the mass changes that happens with the ice sheet.
We develop Arctic solutions, new insights and innovative way of working in the Arctic, and at the same time we use that knowledge to train our students.
We have a Bachelor of Engineering education. The first 3 semesters are in Greenland, where the students focus on field work. We also have a master's education called Extreme Engineering and Cold Climate Engineering. The students are spending at least 1 semester in Greenland. We also have project families. Here students work on an individual basis on their projects, but around a common topic. They get the chance to discuss with each other, so they develop more and get better results.
The work that we do in the Arctic and our presence in the Arctic results in engineering solutions that are tailored for these extreme conditions. These solutions have an impact on climate change discussions across the scientific communities today, but also have an impact on the environmental protections of the Arctic as a whole.
Our very special correspondent Heidi is out on the conference floor asking attendees the question of the day. Heidi, what are we learning today?
I hope to see more public engagement. I hope to see that scientists become better at communicating their science in a way that's accessible to more people so that they can get involved, feel included in helping us to solve the problem.
My hope is that we actually rise to the challenge of climate change, and we actually look at the evidence, use the evidence and integrate it with policy, and actually make the changes and transition to a low carbon economy that we have to make to solve the issue of climate change.
Workforce diversity. I would like to see that we are more of inclusive in our science community for all types of diversity, whether that's physical diversity as far as accessibility needs, ethnicities, cultural.
I hope that in the near future that we can start to center our research around environmental justice.
That's it, I'm afraid, not just for today, but this year in Washington, D.C. and our coverage of the 2018 AGU Fall Meeting. In the meantime, you can watch the show all over the Conventional Centre, in your hotel room and online, as well as on the AGU 4Meeting app. And don't forget to keep up with all the very latest developments and get in touch via the web. Heidi, how are you? How did it go today?
It went well.
How was the question of the day?
Good. There are a lot of people. It's really hard to pick who to ask, and some, quite frankly, shy away from the camera.
And all 4 days, how's it gone for you?
Good. I've been being able to go on the floor and talk to different scientists, attend sessions, and give some presentations myself. And it's been great, but I'm also tired and ready to go home and back to the lab where I'm comfortable.
Aren't we all? So until next year in San Francisco, it's goodbye.
Goodbye.